So in this video, we're going to think about how the failure for markets to account for the difference between private goods and services and public goods and services could lead to inefficient outcomes. So to be able to understand how that would work, we need to first consider what public goods are and how they are different from the private goods and services which we've been studying in markets over the past week. Secondly, we need to be able to place these public goods in that same supply and demand framework so we can show how optimality and efficient conditions are not going to be met by a failure to account for these public goods. So as we're going to see in the next couple of slides, public goods are common parts of our everyday lives. And sometimes the line which kind of differentiates a public good and a private good in terms of our perception of them may not be especially clear. And so after viewing this video, you should be able to understand how public goods and private goods are different from each other, how their differences matter in the supply and demand framework, and this should hopefully allow you to recognize the true value of a good or service in the real world and be able to determine that the value which a good or service would be recognized as having is going to be different whether it's a public good or a private good, and be able to account for that in whatever job you may have, or more effectively argue for greater government funding for public goods for the reasons which we'll cover here in a little bit. So as you can see in this table, I love 2x2 tables. I think they're great ways of distilling information. We basically have four types of goods which we can consider in supply and demand frameworks. So we can look at private goods, we can look at club goods, at common goods, and at public goods. And these types of goods or services are going to differ based on two characteristics: whether they are rivalrous and whether they are excludable. So what do these terms mean? Rivalrous just means that if you consume something, then somebody else can't consume that same unit of consumption. So what is rivalrous? I say here anything from Apple products to actual apples, something that if you buy, somebody else can't buy it. If you eat an apple, nobody else can buy that same apple. Excludable is going to be similar, but it just means that we cannot keep other people from getting enjoyment from the same unit of consumption that we are getting. And so here we can think back to that apples and Apple product example. Those are clearly excludable benefits because when you have, what are those called, AirPods, the little things that you put in your ears? I make myself really old when I say that. Nobody else can listen to those. You are the only ones getting sound from that. Those benefits that you get from that product is going to be excludable. Nobody else can kind of piggyback off and get any of the benefit. As we're going to see here, that is not the same for all types of goods. So private goods are probably the most common, are the ones that we think of in most supply and demand graphs as going to the store, buying something, and other people don't get enjoyment from that product, and you taking it off the shelves means that somebody else cannot take it off the shelf. We can compare these to common goods, which are going to be rivalrous but not excludable. So this, the most common example here are grazing commons, thinking about a patch of land, let's call it like an acre of land in the middle of town, where all the townsfolk would bring their sheep and their cattle to eat the grass. And so if these were grazed too heavily, then the grass would not grow back. It would, the ground would be deteriorated and it would just become a mud pit or dry, barren field. So these goods, these grazing commons then, are going to be rivalrous because any grass that my cow eats, your cow cannot eat. However, they are not excludable because you cannot keep me from enjoying some of the grass that you would otherwise enjoy or that your cow would enjoy. And so without fencing in those commons, without making them private, they're not excludable. However, they are rivalrous. So we're going to be competing over that same grass. There's just no way to ensure who is entitled to what grass. Fisheries generally operate the same way, or at least they do without any form of market intervention, that there is a race to catch all of the fish, to fish for crab, to get something out of the sea so that other boats don't get it first, because it is rivalrous. You get the fish means they don't get the fish, but it's not excludable without government intervention because it's an open sea. So on the opposite end of the spectrum are club goods. And the easy way to remember this is just to think about Costco membership, or if you belong to or know people who belong to golf clubs, that these goods, buying the actual membership, is going to be excludable. That Costco they've got the greeter at the door who checks your card, they can keep you out if you don't buy a membership. So the benefits are excludable. However, they're not rivalrous. It doesn't matter if Costco has 20 members or 2,000 members in Kalamazoo, they're going to be able to provide the same services to all of us who are members of Costco. And so that's an example of a good which is excludable and keep people from enjoying the benefits, but non-rivalrous insofar as the people who do enjoy the benefits are not competing over them. Costco doesn't offer different rates to different members, or I guess they do, but not within the same level of payment. So the last here is public goods, what's going to be the discussion of our video today. And public goods are then non-rivalrous and non-excludable. These are typically goods which would not be provided on the market if it weren't for government intervention or government provision of them. So roads and lighthouses here are the classic examples that when we think of a lighthouse in the 1800s, for example, and you have ships sailing the seas, and if they want to travel safely in ports in New England somewhere or Michigan, and there's all these rocky coasts, how do we keep them safe? Well, we provide a lighthouse. However, the service which the lighthouse is providing is going to be light. You obviously can't keep other people from other boats from seeing that light, whether they paid for the lighthouse or not. And having one boat, one ship view the light does not prevent another ship from viewing that light. So it's going to be non-rivalrous as well. And so as we're going to see in the next couple graphs, when a good is non-rivalrous and non-excludable, then there is a free rider problem, a piggyback problem, where there's going to be an incentive for some people not to pay for it, which is going to result in too few of that public good being actually provided on the market. Okay, so to show why a failure to account for the difference between public goods and private goods is going to lead to an inefficiency, let's first consider how we aggregate demand in the market for private goods. And so what I'm going to do now is draw 3 supply and demand graphs, actually just demand graphs, and show how we add demand in this setting. So if you remember from our list of factors which cause a change in demand, which shift the whole demand curve, one of those factors is an increase in the population or a decrease in the population of consumers for that good. And when the population which consume the good increases, then the demand curve is going to shift to the right. And so let's just think of a simple example where we only have one consumer, and that consumer is willing to pay 10, because the demand curve is going to equal marginal benefit, is going to equal willingness to pay. They're willing to pay $10 for the first incremental, the first marginal unit of consumption. And that is the most they would ever be willing to pay for any good in this market. And let's just say that when the price is 0, the most that they are going to demand is 8. That even if the price, even when it's free, they have no more of a need than 8 units. So if this is the only individual, if individual A is the only individual in this market, then their individual demand curve is the market demand curve. That is the demand curve which would interact with supply. Let's now see what would happen when we add individual B. And let's say that individual B has the exact same demand curve. So just like individual A, they're not willing to pay more than $10 for any unit of consumption, and they would not demand more than 8 units even if this good were free. So how do we add these two? Well, let's again focus on these intercepts, on the corners here of 10 and 8. So when the price is 10, how many units are going to be demanded? What is going to be the quantity demanded when the price is 10? Well, both consumer A and consumer B demand 0 when the price is 10. That is their choke price. That is the highest price that they would be willing to pay. And so we add the market demand, the quantity demanded at every price, to get the new demand curve. And so that would be 0 for the quantity demanded when the price is 10. And so what would the quantity demanded be when the price is 0? So not when the quantity is 0, but when the price is 0. We would know that consumer A would demand 8 units, consumer B would demand 8 units. So the total market demand, the total quantity demanded on the market when the price is 0 is going to be 16. And so we can just add these two. So A plus B is going to equal C, which is the aggregate demand. And we just add them horizontally. We add the quantity demanded at every price, and we get this market demand curve. And so we can see that it shifts further out. It doesn't get higher. So that is not going to be the same story when we consider additions of public goods. So to show how the aggregation, the addition of demand curves is going to be different when the good is a public good versus a private good, let's first consider an example of a public good. So to be a public good, we need to think of a good which is both non-rivalrous and non-excludable, meaning we can't keep people from enjoying the benefits that we're enjoying, but that their enjoyment doesn't decrease the amount that I'm able to enjoy, doesn't impact my own consumption. And so while in 2020, there's obviously the health crisis of the coronavirus, in 2019 in Michigan, we dealt with something very different. We dealt with Eastern equine encephalitis, which was spread by mosquitoes. And so obviously at that point in time, it was a good idea to have mosquito deterrents such as spray or big citronella candles, though apparently citronella doesn't work very well, but just something that would keep mosquitoes out of a given radius. And that would be an example of a good which keeps the mosquitoes out, but it's open air, so you can't keep other people from coming over and enjoying your mosquito-free zone at like a tailgate, for example. And them standing in the zone doesn't impact the efficacy of the mosquito deterrent on you, that it still keeps the mosquitoes away. So it's non-rivalrous, non-excludable. So let's now think about how we would add the demand in this market. And let's think that individual A here has a demand curve which is going to look like this, that the most that they're willing to pay for a candle to keep mosquitoes away is $5, and that even when the price is 0, they're not going to demand more than 2 candles. Let's again assume that consumer B is going to have the same demand curve, that they're not going to be willing to pay more than $5 for a mosquito deterring candle, and that even when it's free, they're not going to demand more than 2. So if this were a private good, we would know what to do. We would just add these two together horizontally. We'd have a, let's take a look at what that would look like. So if private, then it would look like this. We would have an intercept of $5 since no individual is willing to pay more than $5, and that when the price is 0, the quantity demanded would be 4. So we're going to contrast that with if the good is public, and then we can see instead of adding them horizontally, we're going to add them vertically. So we want to think about what is the total willingness to pay. Remember, D equals WTP equals marginal benefit. These are all the same thing. So we want to know what is the total willingness to pay in this economy of 2 individuals, A and B, for the very first mosquito deterring candle. So to do that, we're going to add their willingness to pay to each other, the prices together, and we're going to see that that would be 10. Now, what is the willingness to pay for both of these individuals when the price, for the second candle? Well, it's going to be 0 for both of them. So the total willingness to pay for 2 candles is still going to be 0. And so this is how we're going to draw our demand curves for public goods. And we're going to add those values vertically rather than horizontally, since what we're measuring now isn't the total quantity demanded at a market price. It's going to be the total willingness to pay for a determined amount of quantity. So what is going to happen when we treat a public good like a private good? So to consider this on a supply and demand graph, let's first draw a supply curve. I'm just going to draw this relatively flat to make our point. We'll use green again to represent the demand for private goods, the aggregate demand for private goods. And we remember that we add these horizontally, so we'll just kind of exaggerate this and have it stretch out more horizontally. So this is the D private. And we add public goods vertically. We sum the demand vertically. And so we'll draw the demand up here. It's going to be steeper, but its horizontal intercept is not as far to the right. So this is D public. So how much of the good would the market allocate if we treat this public good as if it's a private good? So if we assume that these demand curves are for the same product, just one of which treats it like a public good, one treats it like a private good, then the Q private would be here, and it would be sold for P private. We could then look at the intersection of the public good demand curve with the supply curve and note that Q public and P public are going to be both greater than the equilibrium price and equilibrium quantity for private goods, or this good if it were treated as a private good. So what does this mean? It means that when we don't treat public goods like public goods, we treat them like private goods, then the market is not going to provide enough of them relative to how much is actually demanded. That if the D public is the real demand curve, then our potential economic benefits, our total economic surplus, would be the area under the demand curve, above the supply curve, for all of the units which are bought and sold. However, when we treat it like a private good, when we treat this public good like a private good, then we are restricting our consumption to the point where we have Q private, which once again means that this whole triangle is then deadweight loss. It is lost opportunities for trade which we otherwise could have experienced. So that is the problem with treating a public good like a private good. And we can think about this, right? There would be far fewer roads. You can say what you want about the US military prison complex or something along those lines, but we definitely wouldn't have the same level of national defense because some people would be trying to free ride off of others. We wouldn't have the same investments in vaccines and cancer research because people would just, people about our age in what I look like Steve Buscemi in that one meme, one of you youths, people under the age of 40 would be saying, no, I'll let all of the older generations pay for cancer research and heart disease research since they need it now, and then hopefully when I'm older, they will have already paid for the solution. So these are clearly the incentive problems with not treating public goods like public goods. And what we just showed on this graph was that we can visualize that in a supply and demand framework as well. So the question then becomes, if this is a problem, how do we fix it? And that is largely what I want to focus on this class to be. How can we use economics as a way to improve the world for everybody? And here the solution can be relatively simple in theory, that if we want more of something, then what we need to do is either subsidize its production or subsidize its consumption. We need the government to step in and say, more of this needs to be bought and sold. And so to provide you with an extra incentive to produce the correct amount, we will either pay you to produce a little bit more or pay you to consume a little bit more. So what does this look like in a supply and demand framework? Well, if we remember that taxes shift supply and demand curves to the left and subsidies shift supply and demand curves to the right, then we could, if we knew the exact equations and the shapes of these lines, we could have a new demand curve which would treat this good like a private good, but it would run directly through this point so that the Q public would now equal Q private plus a subsidy. So this D is going to be D private plus subsidy. And so just adding that subsidy, just paying biomedical researchers a little bit more to help finance the research and development of pharmaceuticals, then that may provide this market equilibrium optimal condition for all of us. So that's one solution to this problem. Unfortunately, there are other types of market failures which we need to deal with, and we're going to learn about those in the next couple of videos.